Hey guys, BuildZoid here, and today we're going to be doing the first PCB breakdown of 2017, and unfortunately, it's not an AMD card, as you can probably guess by, well, this core right here. This is a GTX 1080 Amp Extreme. This is also the same PCB that you would see on a GTX 1080 Amp. It is also the same PCB I'd expect you to see on a GTX 1070 Amp and Amp Extreme, because I don't think Zotac has made different PCBs for those, since they do still use the same pinout for the GPU core. So, yeah. Anyway, actually, one more thing to note about the card. A lot of people requested the 16-phase Amp Extreme. Unfortunately, that's not an Amp Extreme, that's a PGF or PFG edition, and that card is exclusive to China. So I can't get any photos of it to, you know, do anything with, except like that one photo on video cards where you can't really see any of the details on the card. Either way, this is right here is already very, very overkill for a 1080. The 16 phase is just taking that to a whole new level. So, wholly unnecessary, kind of cool that it exists. I honestly wouldn't see a reason to buy it, like, ever. Except maybe as like a collector's item to hang on your wall, because 16 phase VRMs are rare. So anyway, let's get on with this card instead of fantasizing about that other card. This is, you know, a standard GTX 1080, so we have a memory VRM right over here, and that's a two-phase. Behind that, we get the bulk of the cards, the biggest VRM on the card, which is the Vcore, which does include the capacitor bank like that. So, that's your Vcore. There's also a special, well, we'll be going on to the back of the PCB for that, so you'll see that too. So that's your Vcore. Down here is that one minor voltage, which I haven't done one of these breakdowns in so long that I actually managed to forget what that is. Don't blame me. I haven't worked with it. I don't specialize on NVIDIA. And over here somewhere, there's got to be the GDDR5 support rail, unless it could be that. It could be that, but I really, really doubt it. So somewhere in here, there's a GDDR5 support rail. I have no idea where it is. I'd need the card in hand to try find that voltage. This is, I do believe, the 1 volt PLL. My memory seems to be coming back. Hooray for that. Anyway, let's move on to the important parts, because neither of those VRMs that I just mentioned and can't find actually do anything. What's important is your Vcore and your VMEM. Both of these, well, actually, so, you know what, let's just take, yeah, both of these use the same MOSFETs, so there's just a difference in phase count. So first things first, let's take a look at those MOSFETs in one phase. Well, did I mention this is an 8-phase? I think I mentioned that already. Anyway, yeah. So we have 2 low side FETs and 1 high side FET. This is a MDU. So they're all MDU because that's a family of MOSFETs from Magnachip Semiconductor, which is a relatively cheap MOSFET manufacturer. They're not super high quality, but assuming that you can manage to cool their MOSFETs, they actually do perform really, really well. They're just not particularly efficient, which you'll see what I'm talking about later in the video. Well, we'll get to that actually really soon. Anyway, so this right here is a 1513. And these guys over here are 1511s, and they both come with the MDU prefix if you want to find the data sheet for both of them. We have 8 phases, VRM, and yeah, we'll not even bother mentioning their continuous current ratings. We'll just skip straight to what my lovely VRM calculator spat out. So for a voltage, core voltage of 1.3 volts, because this is a GTX 1080, these things do not scale. Pretty much at all. Though admittedly, wait, I can actually tweak the voltage right now, so let's just tweak it up to 1.6. Well, 1.5, because that's what I use for AMD cards. So anyways, at 1.5 volts, this VRM right here is supposed to handle 680 amps straight to the GPU core at 125 degrees centigrade switching at 500 kilohertz. That 500 kilohertz switching frequency is way higher than what I think anybody has ever put on a GPU. Well, I don't think there's a GPU out there that ships with a 500 kilohertz switching frequency. So, yeah. So basically this is sort of a safety measure, because the only way to know switching frequency would be for me to have the card in hand. And since, you know, I can't get everything that I see on the internet, just because I want it and want to make a video about it, means I'm just going to use 500 kilohertz across the board because it's a high rating and it's sort of safe. It gives me a margin of error that I'm okay with. So, that 680 amp number right there, there's a bit of a problem with that because none of these MOSFETs is particularly efficient. So, if you actually try to cram 680 amps through this VRM right here, you end up with a heat output of 122 watts. So, let me get a different, I wanted to do a different brush. But basically, this whole area will be kicking off 122 watts of heat if you actually try to cram that 680 amps of current through it. Which, I don't think you're going to manage to hold 125 degrees. Unless you like put a CPU, you know, air cooler on the VRM or some other ridiculous monstrosity. Because, as I said, these MOSFETs they're not very efficient, but as long as you can keep them really cold, they actually perform really well. Just because they have a really good, they have a relatively high RDS on, relatively slow switching, but they also have a very low thermal resistance internally. So if you put a big enough heatsink on them, yeah, they'll totally do that. Just keep in mind that the heatsink has to be able to deal with 122 watts of power if you actually try to cram that. Now, under normal operations, and way out of, you know, so like 1080, which is under 200 amps, so I'm just going to put in 200 into the calculator. The VRM at 200 amps, you're going to be getting about 23 watts at 200 amps. So, yeah. Under normal conditions, this VRM is fine. If you actually try to push that 680 amp figure, which you can't do on a GTX 1080, there's no way. Good luck with that. If you manage to do that, then you've like shorted the core or something. So, yeah. The VRM is great. There's nothing really worth complaining about. Just keep in mind that that 680 amp figure is kind of unrealistic due to the power draw. Just to give you an idea of how the power draw scales, I've given you 200 amps there. Let's do 400. And for 400 amps, it goes up to 57 watts. So basically, you know, we have 23. That's not much of a 3, is that? To 57 watts at double the current, so 400 amps. This is way beyond what you'll ever probably get a 1080 to do, and this is still relatively coolable. And then if you actually try to hit that 680 amp figure, then you get that ridiculous 122 watts of power draw at 680. So, yeah, keep that in mind. While technically the VRM could do that at 125 degrees, good luck keeping it at that temperature. Other things to note, which I've just scribbled over. These chips right here, there's 4 of them. They're all UPI. I can't actually read the inscription on them, but they are UPI chips, who also made the UP9511P voltage controller on this card. So these 4 right here, these are doublers. So basically you don't, while this is an 8-phase VRM controller, these are doublers. So basically this is not a true 8-phase VRM. You basically get one PWM signal going from the controller to those, and then that splits it between 2 phases. So, yeah. That's not really anything negative as long as they ship it with a high enough switching frequency from the controller's side. That's pretty much everything you need to know about the Vcore VRM on this card. So let's move on to the memory VRM. Same MOSFETs, way less phases. Instead of 8, we have 2. So let me quickly tweak the numbers in the calculator. And yep, and we end up with 170 amps. Maximum throughput at 125 degrees, 500 kilohertz switching frequency, 1.5 volts. So the same settings as always. I'll quickly check what kind of heat output you're looking at, and at that 170 amps, you're looking at about 30 watts. Coolable, yeah, you'll be able to cool that. This is still a very small surface area, but you should be able to manage that, sort of. And anyway, it doesn't matter because GDDR5 and GDDR5X will never ever pull 170 watts, amps. Blech. Screwing up my units here, sorry. So yeah, GDDR5X runs on about 20 watts of power to 30, and well, actually it's less than that. I really wish there was some solid numbers on that, but it's like you only go by the memory maker spec sheets, and then they don't take into account the memory controllers, and it's a bit of a mess. Anyway, GDDR5X should be around 20 watts, maybe less. GDDR5, 35 watts-ish. This can do 170 amps. Yeah, there's no concern ever about this VRM not handling your memory overclock. Just no way. Even if you overvolted the memory, the amount of voltage you would have to set on this VRM for it to get in trouble would be so much that all of your memory chips would fail. So, again, good job Zotac. Nothing really to complain about on this card. So let's go over the sort of special thingies. First of all, for anybody wanting to do a shunt power mod, these are your current shunts. And this one right here should be for PCIe. So basically, what's going on is this one should, well, yeah, actually what's going on is you have this connector which goes through one shunt. So it measures power draw on that connector. Then you have the other shunt which measures power draw on that connector. And then this shunt over here actually measures the power coming from your PCIe slot. So yeah, that's dragged all the way to there on the card. I have no idea why they did that when they have two 8-pins, but they did that. So yeah, that's that shunt. There's no other shunts on the card unless I'm blind, but that wouldn't really be that surprising considering how hard a time I have with finding things. Now then, let's move on to the back of the card, where I just wanted to point out one kind of cool thing that Zotac actually has been doing for a while. This thing right here. It might look like a marketing gimmick, and it kind of probably is, but this is a gigantic polymer flat pack capacitor. These things, basically it's very high capacitance, and it has very, very low ESR. That's the whole point of this package. These things have really, really low equivalent series resistance, which in capacitors basically means, well, that's really good for efficiency, and it's also really good for ripple suppression. So it's really cool that Zotac is using these. I'm not sure how much they actually do in terms of practical uses, as that would require having the card in hand and having another card to compare to, and like hooking up a scope or something to see if, because core voltage, you want to actually see what's happening on these capacitors, because these are right on the back of the GPU. So if you wanted to check how much effect this is having, you'd basically have to compare one, like say a reference GTX 1080 against this card, where you compare how much ripple you measure across the capacitors on the back of the GPU core. Because if that's the same, then this thing is kind of just a marketing gimmick. Anyway, that does cover everything for this card. I don't think I've missed anything. So yeah, overall, great card from Zotac. Well, actually, great PCB from Zotac, because they do use it on several cards. It's on the Amp Extreme. Not sure if it also is used for the 1070s. I do suspect it is. And yeah, I mean, PCB-wise, you're set if you buy a Zotac. I'm not sure about the coolers, but I think if you have 3 fans and a 3-fan heatsink on a 1080, you really shouldn't be concerned. Also, isn't there like an even more extreme? Oh no, that's the Extreme. Yeah, Zotac and their naming scheme is got a bit lost there for a moment. So yeah, oops, sent the card away. Honestly, this PCB is great. It's comparable to just about, well, yeah, it's comparable to the best of the best GTX 1080s out there. So if you wanted to do LN2 on it, you could. The only issue I would see with trying to do extreme overclocking on this card specifically is that for the 1080s, you need special BIOSes. and those aren't available. Like, you can't just take a, GTX 1080 BIOS, mod it yourself, and get your LN2 BIOS. Also, GTX 1080s and basically the whole Pascal line from NVIDIA is riddled with safety features. Lower the shunt resistance too low, safety mode kicks in. Lower the, actually, I do believe if you tweak the Vcore, safety mode, if you tweak the Vcore too high, safety mode kicks in. If you try to bypass the voltage controller, safety mode kicks in. Like, there's just a whole list of things you can't do on these cards. Also, if you try to remove the thermal sensor for the GPU core, which is a good way to try bypass gold bugs, it'll kick into safety mode and you can't actually overclock at all. So basically, overclocking a GTX 1080 without special BIOS support from, say, like Galax or Asus, it's not really going to go anywhere. So even as much as this is a great PCB, I mean, it's great that it's super overkill for air and water cooling, but then for air and water cooling, pretty much anything is overkill, except maybe the reference designed by NVIDIA. That's never been overkill, so yeah. But yeah, I mean, great PCB. It's just a shame that it probably, like, I'm not sure. Maybe you could try Ask Zotac, but last I heard, getting custom NVIDIA BIOSes, even from manufacturers, is horrifically hard. So, yeah. Air cooling, water cooling, fine. LN2, I wouldn't try it, but then again, I wouldn't try LN2 on a GTX 1080 in general, just because of this, just because of how Pascal behaves in terms of overclocking. So that's that for this video. There is a subscribe button if you're new to the channel and haven't subscribed yet. If you have subscribed and you would like to be aware of everything I do all the time, 24/7, and have it spammed to your email, there is a bell button next to the subscribe button on the channel page or under the video. It's somewhere. And basically, if you want to get spammed about everything I do on YouTube, well, you go click that, and then you get notifications about it straight to your email. So, yeah, that's that. Actually, no, wait, before you leave, I have a Patreon. It would be great if you, like, patronized me. And that would help out with bringing out content that isn't just scribbling on photos like this. And that's that at this point. I don't think I'm forgetting anything at this point, so let's wrap it up right here and see you guys next time.